depending on where you are. I'm really glad you are here today because this is one of the most practical and important skills that you can learn in research to match your research design to statistics. And I'm really glad to see some of the same faces I see every time I'm teaching here. So welcome again. And our topic is about how to choose the right statistical method based on the kind of study that you are doing. And don't worry, this is not about memorizing any formulas. It is about understanding the thinking behind your choices. So think of this like using a map. We start with the research question, then we pick the type of study, and then decide what kind of data we collect. And only then do we choose the right statistical tool to analyze it. And here's what we're going to learn today. You will be able to tell what kind of study somebody is doing, figure out what kind of data they have, and then choose the right statistical test that makes sense for that situation. We will walk through real examples step by step as well. So why does this all matter? First of all, if you pick the wrong test, you might get the wrong answer. And that could lead to bad decisions, especially if you're going to publish the research. For example, if you're testing a new medicine and you choose the wrong method, you could wrongly say if the medicine works or doesn't work in a certain population. Also, if you ever want to publish your work, reviewers will check to make sure that you have used the right methods. And this is why sometimes peer review comes back and they will have questions about what exactly methods you used, what statistical tests you used to make sure that your study was valid and that you did the right thing with your results. And you might have heard of the term quantitative research. So why choose a quantitative study in the first place? Well, quantitative research is about using numbers to answer questions. If you want to measure something, for example, blood pressure or number of hours that people sleep, or any type of test scores, then you are doing quantitative research because you have numbers. It also lets you test ideas like, does this treatment work better than the other one? Or is there a link between stress and sleep? And with enough people, you can also make general conclusions. If instead you wanted to understand people's experiences or feelings, then you would probably use qualitative research, which is usually done through interviews or focus groups. But I think that most applicable for most of us, also including my research, is quantitative research, so actually collecting numbers and results in the form of numbers. So this is the main idea I want you to remember first. So ask your question. So what is your research question? And then think, how will I study it? What kind of data do I need to collect? And is it numbers or categories? And finally, based on all of that, you will be able to choose the right statistical test. If you will try to start with the statistics and go backwards, you will get lost. So you should always start with your question. And let's quickly look at different types of studies. So descriptive studies tell us what is. Correlational studies ask, are these two things linked? So are they correlated? Experimental studies test what happens when we change something, for example, giving one group a drug and the other one a placebo. Quasi-experiments are similar to experimental studies, but they're not perfectly controlled. Then we have longitudinal studies, which follow people over a period of time, while cross-sectional studies look at one moment, for example, a survey study. Case control and cohort studies are very common in health research, and they look at who got sick and why they got sick. And here we get to our first example. So in this example, we are testing a new drug. We randomly put people into two groups. One gets the drug and one gets a placebo. Then we, for example, measure their blood pressure because we're comparing two different groups and the result is a number. We would use an independent t-test. Independent means that people in one group are not the same as the people in the other group. So the people who were receiving the drug are independent of those who were receiving the placebo. And here we, of course, would not use a paired t-test because these groups, as said, are separate and independent. So as you can see, the name of the statistical test is already hinting you at what you're looking at. And we also don't need a more complex test here unless we had more than two groups. So if you remember, we spoke about different types of statistics, and we said if we have more than two groups, we would use a test called the ANOVA. But in this case, we only have two groups, so we stick with the t-test. And I also recently conducted a survey study on shared decision making between patients and healthcare providers. So I have two independent groups, and I ran the independent t-test on them to see who has a higher perception of shared decision making. And it turned out to be, of course, the healthcare providers, just like I hypothesized. And also the results were significant. So healthcare providers were significantly perceiving higher engagement in shared decision making than the patients. For example two, let's say that now we are just observing. So we have no groups and no experiment. We ask people how stressed they feel and how many hours they sleep. So we're just looking to see if there's a pattern. And in this case, we use a Pearson correlation test. Again, something I mentioned in a previous lecture when we discussed the several tests. And the Pearson correlation will give you a value that is a number between -1 and +1 to show if the two things like go together, let's say up or down. So if they have a positive or negative correlation. So if stress goes up while sleep goes down, then we would have a negative correlation. And if they both go up, then it's a positive correlation. And we're not saying that stress causes sleep changes, just that these two are correlated. So they have a relationship or an association, but we cannot establish a causal relationship from this type of study. Further, for example, 3, we have repeated measures, so before and after. And here we test the same people, in this example, before and after memory training. And because it's the same people, their data points will be linked, and we call that paired. So in this case, you do not have two separate groups like we had with the independent t-test, but here we would have to use the paired t-test because it's the same group of people, just before a certain intervention and after. And the paired t-test compares their scores before and after. And here, if you use the independent t-test by mistake, we would ignore that connection and get less accurate results. So we have to know that we have a connection, that we have the same people both times, before and after. And if we had more than two time points, say before, after, and even some follow-up, then we would need something like a repeated measures ANOVA. And this is where it gets even more complicated. But the first step would be for you to realize that whatever test or experiment you're conducting, the first thing you should ask yourself is, am I comparing two separate groups of people, or are they the same people, just at different time points? And from there, you can identify if it's independent or a paired t-test. Now, example 4 is a case control study. And we look backwards in this case. So we take people, for example, who have Parkinson's disease and compare them to people who do not have Parkinson's disease. And then we would ask if they were exposed to, let's say, pesticides. And the outcome is a yes or a no. So we would use logistic regression, which helps us estimate the odds that exposure is linked to the disease. This is often used with such environmental factors, or I know that they use that also, for example, to identify any causes that could be to cancer, because they take a group of people and they look at some certain exposure that they had before. This is why we always look them backwards. That's a case control study. And so we're investigating these odds, or let's say estimating them, that a certain exposure, in this case pesticides, would have caused Parkinson's disease. And here we would not use a t-test because our outcome is not a number. So it's a category, which in this case is just a yes or a no. So what are the odds that a certain exposure, so here a pesticide, caused the disease? Further, we move into cohort study. A cohort study is when we follow people forward in time. So we want to see, for example, who would get cancer and when they would get it. And some people may not get it at all during the study, so their data is so-called censored. That means that they didn't have the event by the end of the study. And again, you might remember from one of our previous lectures, Cox regression, also called a survival analysis, and it is designed for this kind of data. It tells us how long it takes for something to happen. And for example, if we're looking at lung cancer, it would tell us whether being a smoker changes that time for something to happen, in this case, causing lung cancer. And then there's so-called quasi-experimental studies. These are more complicated studies, and we don't talk about them so often because I think they're more rare. But sometimes you can't randomize people like you do in, for example, a controlled trial in clinical trials or something. So here an example would be a school. So a school decides to try a new teaching method in one class, and you measure test scores before and after in the students. And since we're looking at the same students, then you can use a paired t-test to compare the scores. But what if you want to measure not just before and after, but also how scores change over several weeks? So we're not just looking at before we implemented the teaching method versus after it's been implemented, but we actually want to see the change. Like we started teaching this, and is it improving over time, or how exactly the change happens? So, or you would want to compare students from different classes, and then you would need a more flexible tool, which would be called a mixed model. And a mixed model can also be called a multi-level or hierarchical model. And it's a type of statistical analysis that can handle repeated measurements, group differences, and individual variation at the same time. So you can hear that this is why it's called mixed model, because it mixes fixed effects. So for example, the teaching method with random effects, which are like differences between individual students or schools. And this would allow you to use all of your data, even if not every student has the same number of test scores or the same schedule. And mixed models are very useful when your data is grouped or collected over time. But again, as said, so this is a non-randomized study, and this mixed model is more complicated. And here, this is why I gave an example of a school with a teaching method, because it is often used in educational research. So if you're going to be looking at clinical research or healthcare research, then these studies are very, very rare, because in most cases, you will be using randomized experiments or survey studies or something else. And seventh example here is a cross-sectional survey. So now we look at a survey that asks about income levels and health satisfaction. And in this case, both are categories. So you can use a chi-square test to see if there's an association. And as we identified in my previous classes, association is a synonym of a relationship or a correlation. So if the satisfaction scale has an order, for example, low, medium, high, then you could also use ordinal logistic regression to model how predictors affect the ordered outcome. And I made this summary table that summarizes everything that we have covered regarding these examples and the different types of studies. And you can keep this for reference when you are planning your own study or reading a paper or whatever. And I can also suggest that for any research question, anything that you have come up with and you're designing a study, you can use AI, but you should not expect that AI will give you the correct statistical tests from scratch or even run the statistics for you. it's not going to do that. And if it does, it might also be wrong. So you should instead use AI as a support tool. You can ask it questions about different types of statistical tests and give it your thoughts on what tests you want to use for your specific data, for your specific research questions. And let's say have a conversation with it. You probably guys have already tried out how AI works, and it can be a really, really good support tool in this case. And it will give you advice and tell you if you're on the right track, or maybe point you in the correct direction if you're not. And just remember that you should be using AI smartly, which means that using it as a support tool and not a replacement for your research responsibilities and for, let's say, conducting the study for you. It's not going to do that. And some final thoughts on this matching the certain research design to statistics would be to remember that you always begin with your question, and then you decide what kind of study fits. Understand what kind of data you are going to get from it, and then only choose your statistical test. If you do it this way, then you will always be able to explain and defend your choices. So your research questions, so one study can have multiple research questions. My latest one actually has 5, so I have 2 primary and 3 secondary research questions. And from them, I always make a draft. So I have my research questions, and then I start drafting my methods based on them. I start playing around with different statistical tests. So what exactly I want to find. And I make a so-called outline, which really, really helps me. So I start looking, okay, I have these 2 groups. I know that I have independent groups because I have patients and I have healthcare providers. So what do I want to see? Do I want to look at differences in certain scores that they did in my survey? Then obviously I am doing an independent t-test. Then if I want to see if any demographics are influencing what, let's say, responses they're giving to my questions, then I'm going to start running logistic regression analyses and stuff like that. And the best way to do that is always make a draft and an outline and do a lot of, let's say, brainstorming and whiteboarding. That's what I like to do for research and for statistics because it's the best way to figure out the right path. And I also think that I mentioned to you guys previously to not be afraid to make mistakes because those are what you're going to learn from. And we also spoke about research teams last time. Most research, especially if you're going to conduct a real study that you will publish, you will not be doing it alone. You will be doing it in a research team. So this is another opportunity for you to discuss with other researchers. What are your thoughts? And so to say, maybe ping pong some ideas back and forth, and in that way land in the correct statistics. So those are also some tips from my side. And today, I know that you usually have a lot of questions. So today I also want to take that time to spend the rest of this class to answer specifically, maybe it's about your specific research or in what way I can help you understand your research design, what you want to do, and how you can match the statistics. So I hope that I can do that in the remaining, let's say, 40 minutes. So does anybody have any research projects, anything that we could discuss?
Oh, excellent. We have a lot of time for questions. This is excellent. I have the first question.
Yeah, that's what I wanted. Yeah.